This brings us to Istio, and this is the architecture diagram of Istio. So it's very similar to what I just showed you. Istio uses the Envoy proxy for the sidecar deployment. It's a very efficient proxy, very lightweight, that you can then include in your pod. So if you have app1, which is a microservice, you can have this as a container in your pod, and then next to this container, you will have an Envoy proxy within that pod that will deal with all the communication. So the envoys will communicate with each other. You can do this encrypted with authentication, so that only those apps within the service mesh can communicate with each other and not outside apps. And you can have policy checks, telemetry, so you can gather your metrics and can get some insights of your traffic. And you will have your configuration data pushed from a central application, pushed from your Istio. So all the configuration decisions are made centrally and then pushed through all your Envoy proxies. And Citadel on the right here can also provide TLS certs for every Envoy proxy. You can then also have authentication using certificates. And this is all managed by the control plane API, which allows for central management of this service mesh. So once you start using microservices, when you have a service mesh, Istio is a great solution to get a whole new feature set rather than implementing this on the app level. In the next demo then, I will show you how to deploy Istio to your Kubernetes cluster. In this demo, I will show you how to install Istio. There is a directory Istio in the Kubernetes course where you will find the YAML files and the README. To install Istio using kops, we have to make some modifications to our kops cluster. So what I'm going to do is I'm going to launch a new kops cluster. I'm going to use kops create for that. It's the same command as we used previously to spin up a cluster, except this time we're going to use node size T2 medium instead of T2 micro. This will give us a lot more memory in our cluster to launch applications. This is because Istio needs memory for its processes to start. So the pilot process now needs 2 GB of memory. So to make sure that we have enough, we're going to use T2 medium, which provides 4 GB of memory. I then execute this command to create this cluster. So let's have a look at the README. Kops added cluster, Kubernetes New Tech Academy, plus the state, and we have to add this. The Kube API server admission control, and we need to make sure that we include all these elements to the admission control because Istio needs those features. Let's do kops edit cluster, Kubernetes New Tech Academy with the state. This will open the editor, and then here we have the specification for our cluster, and here we can add the lines. You can add them under spec or just at the bottom. The only thing that you have to make sure is that the indentation is correct. So this is Kube API server and then the admission controller. Also check whether Kube API server hasn't been defined yet. In our case, it hasn't. This is the only Kube API server that is in the specification. Then we should save this. If there is an error at this point, check the indentation again, because kops will give you an error if there's something wrong. Now we are ready, so we can do kops update cluster -- yes with our state from S3. This will then spin up the cluster. You'll have to wait again a couple of minutes, so I will pause the demo for a couple of minutes and start again when the cluster is reachable. Cluster is starting, should be ready in a few minutes. Let's have another look at the README. We can download Istio. These are the instructions for the 1.0.1 version, or you can download the latest version. I'm going to download the latest version that's currently available, which is the 1.0.1. So I'm just going to copy paste these lines. I'm going to execute them. So this will download Istio 1.0.1 for Linux. It will extract it in my home directory. So I have Istio 1.0.1 in my home directory, and it's also going to add this export path to my .profile. So every time I log in, this path, this bin directory will be added to my path. So that everything that is in this bin directory, the istio.ctl, will be in the path. So I will be able to execute this command. To make this work, either you have to log out and log in, or you can just execute this, and then you should be able to execute istio.ctl. So that seems to work. So Istio configuration command line utility is now available for use. Let's go back to Vagrant, my Kubernetes course Istio directory. Let's have another look at the README. So now I can install Istio from the Istio directory using this command to apply the CRDs, the Kubernetes extensions, and then I can choose to install Istio without mutual TLS authentication or with mutual TLS authentication. If you enable with, then there will be authentication on your microservices, but it also means that you cannot reach your services if you don't have a certificate. So it might make it a bit more difficult if you already have services running on Kubernetes. So then to get started, it's probably best to use without authentication. And then when you want to bring it to production, you can enable authentication. So let's execute this one first. kubectl apply the crds.yaml. So now it's applying all the custom resource definitions that are going to be used by Istio. You should now wait a couple of seconds, minutes, just to make sure that those CRDs are created properly. And then we should be able to install Istio. We're going to install Istio with no mutual TLS authentication for now. Now it's creating all the Istio resources. And now we have Istio successfully installed. We'll have to wait a little bit until Istio is completely started up. So we have a namespace Istio system where all the containers need to be created first. Give it a couple of minutes, and in the next lecture I will show you a demo app. In this demo I will show you how to deploy my Hello World app, the first Istio enabled app that we will deploy to our cluster. Let me first show you an architecture diagram so that you have a high-level overview of what we are going to do. I'm going to use curl, which is going to be the client, to contact an app. This app will be a microservice that is not going to be one app, but multiple microservices. Now that I have deployed Istio, there will be an Istio ingress and an AWS load balancer pointing to this Istio ingress controller. So if I contact this AWS URL, this AWS load balancer URL, I'll be redirected to the Istio service and to the Istio ingress controller. I will have to do some configuration to make sure that the Istio ingress knows how to contact my app using some YAML definitions that I will show you in a moment. This Istio ingress will then contact my app. Rather than contacting the container directly, it will contact the Envoy proxy, which is deployed as a sidecar in the same pod. So we have one pod, two containers. One is the real app, which is called Hello, and one is the Envoy proxy deployed by Istio. It will contact this proxy, and this will contact my app Hello. This Hello app is configured that it will go to another app called the World app to get some of its information. When Hello is contacting World, it will use the Envoy proxy again. So this goes over the Envoy proxy to the World app. The World app is also configured to contact the third app, World v2. So it will also go over the Envoy proxy to contact World v2. At this point, everything is sent back to the Hello app again, which now has enough information to send back the data to the client. So the client will then see, using curl, it will then see the string that has been returned by the hello app, the world app, and the world v2 app. I only show 3 pods here, but actually my deployment will have 3 pods per deployment. So in total, I will have 9 pods, 3 replicas for every deployment. So let's have a look at the YAML definitions of these files. So the first file I want to show you is the hello world YAML file. I don't define any Istio proxy in this file. This will be injected by the istioctl command. So this just looks like any deployment that you would write in a YAML file for Kubernetes. So I have a deployment called hello, 3 replicas. I have 2 labels, app hello and version v1. This will spin up a container with name hello, and the container is called HTTP echo. And you can have a look at my GitHub repository. There's a repository HTTP echo to look at the code, but it's a very simple app. It will just output whatever you pass as an environment variable text. So in this case, it will return hello. It will also have a look at the environment variable next, which identifies the next service it needs to contact. The next service in this case is world on port 8080. So it will append the text that it gets from world. So this one outputs hello, and then for the rest of the text, it will go to the next application. We have one port defined, HTTP port on port 8080. We also have to use the word HTTP so that Istio recognizes it, because then Istio will use the HTTP protocol. We also define a service with the name hello, also name of the port HTTP, and the port that we need to contact is 8080. Then we have a second deployment. This one is called world, and world is also using the same image, and the text that will be returned in this case is going to be world. So we have one app that is going to return hello, one app that is going to return world. And the next app that it needs to contact is world v2 on port 8080. The rest is all similar. Let's have a look at this third deployment, world v2. Text in this case will be 3 exclamation marks. And there's no next defined, so this service will just return this. So now you should already have an idea of what the app is going to do. If we're going to contact hello, then it will output hello. It will contact the next app, which is world. If we have a look at world, it will output the text world. We'll go to the next app, the next microservice, world v2, and world v2 will output 3 exclamation marks. And this one also has a service. So let's deploy this one. How do we deploy this? Not just by kubectl create or apply, but let's use istioctl. You can copy paste it from the README. We need to use istioctl kube inject of this hello world YAML to inject the proxy. I will execute this first without the kubectl apply so that you see what happens, and then I will do a kubectl apply. First, make sure that your path is set correctly. So I'm going to just set the path so that I have istioctl in my path. Let's have a look what istioctl kube inject outputs. It will output everything in YAML format, but what it's going to do is it's going to add another container. It's going to add another container starting from here, args, and this is going to launch the Envoy proxy as a separate container within the same pod. Let's apply this, kubectl apply -f, and then we're going to execute this so that we inject the Envoy proxy. So this will launch the 3 deployments with each 3 pods. Let's have a look at the get pods. You see 3 pods each and 2 containers in every pod. One for the app, one for Envoy. Now, if we want to contact our application, we want to typically contact hello, then we also need to define the gateway, the Istio gateway. Let's have a look at this file. We have kind gateway. This will select the ingress gateway. So this is the default gateway, the default controller. This is the default controller that is already available. We're going to say we want to use port 80 on this ingress controller. Everything that matches, we want to capture using our gateway. You can specify a host here, a host name, or you can just capture everything. Then we're going to have a virtual service. Again, you can specify a host. If you don't specify a host, you can also specify a star. This will match everything. So our virtual service is basically our service that we want to define. The gateway that we use is the Hello World gateway. So it's going to be this gateway. We're going to say HTTP match URI prefix /hello. So whenever we go to our ingress controller, then if the prefix matches on /hello, then we're going to route it somewhere. We're going to route it here. Our destination is going to be the host hello default SVC cluster local. So this is going to be the host name of our first app, the Hello app. Default stands for default namespace. We're going to do that on port 8080. So typically you always need a virtual service if you want to define your service in the ingress controller. You always also need one gateway. This is our gateway that we're going to use. So we have one gateway and one virtual service. If you want to directly access other services, then we just have to define multiple virtual services. We don't need to define a virtual service for World and World v2 because those will be accessed by the Hello app, not by the client itself. kubectl apply Hello World gateway. This is created. Now let's have a look at the service of the namespace Istio system. So here we have the Istio ingress gateway. Let's do all wide. So here we have the full URL of the load balancer. And then if you do curl of this URL, we don't get anything because we haven't configured anything. Let's have a look again at Hello World gateway. We only configured something for /hello. So let's use this URL /hello. And what do we get? We get Hello World and 3 exclamation marks. So this comes from, the hello comes from one of these spots, the world comes from one of these spots, and the 3 exclamation marks comes from one of these spots. So these communicated with each other over the Envoy proxy to get this string of information and send it back to the client. The client only accessed the ingress controller. The ingress controller contacted the Envoy on this application then contacted this one, and then this application contacted that one. So this is an example of a microservice with the Envoy proxy deployed as a sidecar using Istio. In the next demos, I will then show you some more features of Istio to show you really what the benefit is of having Istio running in your cluster for your microservices. In this demo, I will show you how to do traffic routing with Istio. I'm going to create a V2, a version 2 of my Hello World app. So we still have the Istio ingress controller, and the Istio ingress controller will redirect to the version 1 of my Hello pod, and this Hello pod will connect to World and World 2. I'm going to add a new pod, Hello V2. It will be a new deployment, but the app label will be the same. So the service for Hello will route to Hello and Hello V2. The distinction between the apps is going to be in the label version. The first pod has version v1 and the new pod will have version v2. In the Istio rules, I will then have to define some new rules to route the traffic, not to both pods, but depending on the version number, I want to route all the traffic to the first one, and only when it matches some specific rule, I want to send it to Hello v2. So in this demo, I will change the virtual service rules, and I will say that if the host is hello example.com, then route it to version 1. If the host is hello example.com and the header and user is equals to John, then send it to v2. And this is actually quite powerful that Istio can do this, advanced routing rules, because you could make your app in a way that if a user is logged in, that you pass a header or a cookie or something that identifies that a specific user is logged in. And only when this user is logged in, then you will show the new version of the app. That way you can test your app on the cluster with Istio, but no users will see it. Only this specific user, this end user John, will be able to see the new version. So that's what I'm going to show you now. So I have a hello world v2.yaml. This is deployment. This deployment is called hello v2. Still 3 replicas. The label is still app hello, but here the version is v2. This app will output hello, this is v2, and it will add the content from world 2. So these are the 3 exclamation marks. So let's have a look at our first deployment to see the difference. So we have hello world.yaml, and here we have metadata name hello. So this is different because now we have v2, but here we have the same app label. The label app is hello, and this is version 1. So what will happen is that if you wouldn't use Istio, then we would have a service that selects on app hello. So it would route it to both the earlier hello deployment and both the new v2 deployment. So that's not what we want. We're going to create some rules to distinguish between those. And those rules I have in hello world v2 routing.yaml. This is of kind destination rule of the Istio API. I'm going to call this hello. And I say if the destination host is hello default SVC cluster local, so this is our hello service within our cluster, then we're going to have 2 subsets. We're going to have subset name v1, and that will be routed to the pods with the labels version v1, and we will have a v2, and this will be routed to the pods with the labels v2. I just have to update my virtual service now. So this is the same virtual service I created earlier. I will now override it. I'm going to specify a host, helloexample.com, so I'll have to pass this. Still my hello world gateway, and then I will have a default route here at the bottom. So if nothing matches, then this route will be used. So this will be the host hello default SVC cluster local, but it will use subset v1. Then I have a matching rule. Here with this matching rule, I have headers. Right here, headers, end user exact John. So this header end user is a key. John is the value. This needs to match. If this matches, then I will route this to the destination hello, but subset v2. Let's test this out. I will have to add my v2.yaml, and I will apply my hello world v2 routing.yaml. I destroyed and spun up my cluster again between the demos, so let's have another look at the service of Istio system. This is my load balancer. So if I do curl /hello, it's not going to work anymore because I applied different routing rules. I still have only one virtual service. I just have overridden it with my v2 YAML file. So this actually gives a 404, not found. If I want to reach my hello world app, I need to pass a host name now. So host helloexample.com, and then I get my hello world. So this is the URL that normal users use. People will get the hello world URL. Now I want to reach v2, and the header that I can use is end user John. And if this header is set, by example, this can be set by your login code on your website, then I'm going to get hello, this is v2. So this hello, this is v2 comes from the hello app, and these 3 exclamation marks come from still the world 2 app. So this is how you can direct traffic and put advanced routing rules within Istio to redirect traffic to one app or the other app.